What's up, everybody? Welcome to the channel. We are here today to walk people through how to do the statistics portfolio assignment. People are asking for a video, so here you go, you got it. I am going to go right from the top to the bottom, objective 1s through objective 6, show you how to do this project. Let's jump right into it. In order to do this project, you're going to need to have a couple things open. You're going to need to have a blank Google Sheets document. You're going to need to use this Jamboard document, which I don't need that title anymore. I'm doing a new project today. So just totally blank normal distribution jam topic. You're going to need some data. I'm going to use the data from the New York Jets. Very easy to find. As I said in class, I highly recommend sports data. It's just easy to find and work with. I think other data could be more interesting, but you have to actually go and get that stuff, and that could be difficult. The other thing you're going to want is just a blank Google Doc. You're going to need Delta Math open because specifically you want to use that stat calculator in there. It seems to be having a problem loading. Come on, Delta Math, get it together. Cool. So let's jump right into it. Yeah, you're going to need your stat calculator on Delta Math. Let's go into it. I'm going to go through objectives 1 through 6 so you can do the project from start to finish. For the portfolio assignment, the first objective is to identify a quantitative variable of interest. Remember that quantitative is numbers. And numbers that have like actual value that you can put in order, not like zip code, not like phone number. Those are not quantitative variables because they don't have any meaning. What I'm going to do is I'm going to pick my variable of interest, and my variable of interest is going to be how many wins did the Jets get per season? What do they typically get per season? This year they're not doing too hot. It's 2020 right now at the time that I'm creating this video, and they have 0 wins. Luckily for the Jets, I'm not going to include the 2020 season because it's still underway and all the games aren't finished. So step 1 is I picked what my data is going to be on. It's how many wins do the Jets typically get per season, right? That's part 1. I've already picked it. Pretty easy, right? We're one step down. Look at that. I did objective 1. I identified a quantitative variable of interest. There's some nice examples down here that you can do as well. Step 2 is kind of a tricky one. We got to gather that data. So luckily I've already found the data, and sports data is easy to find, and now I just kind of got to collect it and gather it. So here's the data, and I'm only concerned about wins. I don't care about points for, I don't care about points allowed, yada, 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 but those are kind of cool things to do. So let's go and just grab this data here. So I am going to jump over to my Google Sheet. I'm going to type in the year, and I'm going to type in the wins that the Jets got. And what I'm going to do here is a little trick. I'm going to start with 2019, and rather than manually write 2018, 2017, 2016, 2015, I can use a formula, and the formula looks like this. I hit the equal sign. Equal sign says you're starting a formula. I click the cell that I want, 2019, and I just subtract 1, enter. Boom, it says 2018, and now you may be saying, that's not that great, Mr. R. I could have just subtracted 1. But wait, the formula's there. Look, it says the formula in the cell. It doesn't say 2018, and when the formula's there, you can just drag this down, and voila! Oh, that is pretty darn sweet. That is pretty darn sweet. I got them all. Got all the years I want. Now I'm going to manually write the wins. This is a little bit time consuming, but it is what it is. This is part of being a statistician, is doing tedious amounts of data. So I'm just going to put these tables side by side so I can look at them at the same time. I'm going to skip 2020 because this year is still underway, and that's lucky for the Jets because they have stunk it up this season. All right, anyways, let's go. I'm going to go. 2019 looks like 7, 4, 5, 5, 10, 4, 8, 6, 8, 11. So 11 should be 2010. I'm going pretty fast. Cool. 9, 9, 4, 10, 4. 9, 9, 4, 10, 4. 4 should be 2005. Great. 9, 9, 4, 10, 4. Then it went 10, 6, 9, 10. 10, 6, 9, 10. All right, they were good for a little bit. They had a good defense. They had Mark Sanchez, who was pretty all right. They had Darrell Rivas on defense. Rex Ryan coach. They had some good years in there. So let's see, 2001 was 10. I'm still going. I'm going to scroll this up to 2000 now. 2001 was 10. So I'm losing track. This is what happens when you look at the data. It gets tough sometimes. 2000 looks like it goes 9, 8, 12, 9, 1, 3, 6, 8, 4, 8. That was 1991. Then I'm going to go 6, 4, 8, 6, 10, 11. All the way down to 1985. I'm going to go 7, 7, 6, 10. 7, 7, 6, 10. And I'm going to put in 1980. 7, 7, 6, 10. 1984. That's going to be enough data. You might ask, how much data do I really need, Mr. R? You need about 30 pieces of data. The more you have, the better. But I don't want this video to be too long, so I'm going to stop there. Now, one thing I like to do is I'm a neat freak, so I like to go and organize my data. Here's what I do to do that. I highlight it all, click on the 3 dots. I go center. It centers the data. That's kind of a beautiful thing. I click on the grid marks. I say, put those borders in there. Wow, that is looking fancy. I can get rid of my Jets encyclopedia. Don't need that window no more. It's done. And then what I like to do is I like to maybe put a sweet background color here. So I'm going to pick a background color. Where are those background colors? A fill color. And I'm going to do like a sweet Jets green. Ooh, that's fancy. Great. Now back to the project. What did they want us to do? They said gather the data. We definitely just did that. And then use Google Sheets to find the average. There's the formula. Equals is a formula. And standard deviation. So this is big time here, right? So first thing I'm going to do is find the average. I'm going to hit equals. And that's going to indicate a formula. And I'm going to start to write average, AV. And as I do, let's get rid of this. Too many windows open. No. So unclick the 3 dots. Let's do that again. I'm going to hit equals. Average, AV. I could write the word average, but it shows up here in my possible formulas that Google thinks I want. So I click average, they're right. And then I can either highlight all the terms or just click the column. So I click column B and it finds the average. The average amount of wins the Jets get is about 7.15 based on the data I contributed. And now I want the standard deviation equals STDev, standard deviation. And then again, click column B. Boom, there it is, about 2.6 standard deviation. Now I like to make a table because I'm neat. So I write average, I write standard deviation. I might extend column E a little bit so everything fits in there. Now highlight everything, do some formatting, center the stuff so it's nice. Ooh, maybe hit a little grid. Ooh, that's nice. And then go in here with some fill color with some like Jets green. Ooh, that's a nice green there. And there I have it. Now I want to round. I could round these by hand. Maybe that's a good option for you. I'm feeling like I want Excel to do all the work today or Google Sheets. So I'm going to highlight the cells. I'm going to go to format. I'm going to go to number and I'm going to round it. I'm going to click on more formats. I don't know why 10th is not a standard format here, but I click more formats. Why don't they have 10th? Yeah, I want it to do a number, but I want it to be like a 10th. More formats. More date, custom number format. I don't know why it has to be custom to do 1 decimal place. So I'm going to click on this one. And then this is to 2 decimal places. I just delete one and they're applied to 1 decimal place. You could round it to 1 decimal place yourself. Great. I've done all of this and I've now completed step 2, objective data. I did the research. I found the data. I copied it into Google Form. I got my average. I got my standard deviation. We are rocking. Let's move on to step 3. Step 3 says to label a normal distribution curve. This is a big part because it's leading us into the questions that follow. When we do this part, we're going to label the normal distribution curve once, and then we're going to copy that slide like 4 or 5 times so we can use it for parts 4, 5, and 6. So let's start by labeling the normal distribution curve. First thing I want to do before I label my curve is I want to go here. I'm going to go View. I'm going to get rid of the grid lines. And I'm just going to screenshot, which on a Mac is Command-Shift-4, this beautiful data that I have because I'm going to need that. Great. Now it saves that to my desktop. It's right here along with my Jets logo that I saved earlier. So I'm going to say this is bell curve stuff, right? Stuff I need for the bell curve. And now I go here to my normal distribution jam. When you get this document, you should go, it's attached to our Google Classroom, but you should go File, make a copy. And when you make a copy, you want to like name it something sweet. So I'm going to name this like New York Jets season wins. And then I'm going to write like Mr. R. Because remember, you're eventually going to hand this thing in and you want to have your name attached to it because you're giving it to me and like everybody's got all these names rocking. Cool, so let's title our slide here. These ones down here at the text box, we'll do that. Click text box, look, it's already on title, and I can say, how many wins do the New York Jets typically get per season? And now that font is just rockin' large. So what I can do is if you drag from the corner, it changes the font size. Drag it, and I think that's pretty good, and it's a question, so I'm gonna click edit, make sure I got a question mark there. And then I'm gonna say maybe like enter, maybe I'll do something here like by Mr. R, right? So everybody knows that I did this project. It's my name is just written all over this thing, right? Now I want to sit there and make it a little bit fancy, so maybe I'll add an image. Well, I happen to have this Jets helmet, which I'm gonna drop in there, right? We're talking about the Jets, so might as well drop a Jets helmet in there so people know. Don't want to drag that. I kind of like the curve where it was. I'm gonna move the Jets helmet maybe over here. Doesn't need to be so large. And then very important, I'm gonna import another picture, and this time I'm gonna put in my data that I found. I'm gonna put in the mean and the standard deviation. Drop that up there because that's very important. You can see it's cool that I use that jet screen because everything is like matchy-matchy now. And now it's time to actually fill in my data, and I need to fill in this data table down here. All right. So I don't need it to be title large, maybe just normal size is cool. And I'm gonna fill in this chart. Well, the first piece here is the value that's 3 standard deviations below the mean, right? So if the mean is 7.2, 3 standard deviations below that is going to be 7.2 minus 3 times 2.6. So I'll do that in delta math. I'm just gonna open up the regular calculator. I'm gonna do 7.2 minus, and then I'm going to put in parentheses 3 times 2.6, right? Because I'm subtracting 3 standard deviations. Hit enter, and I get negative 0.6. Negative 0.6. So I'm going to go over here, and I'm going to write edit, negative 0.6. The Jets aren't too hot. And I just have to keep adding that 2.6. If I add 2.6 again, I get 2. If I add 2.6 to 2, I get 4.6. If I add 2.6 again, I should get 7.2 because under 0 is your mean. If you ever lose track of it, you have to go back and press edit. So I get 7.2. That sounds correct. And then I'm going to add 2.6 again. I'm going to get 9.8. I'm going to add 2.6 again. I'm going to get 10.4 when I add 0.6. So I'm going to get 12.4. Hopefully my math is correct. I'm going to add 2.6 again, and I'm going to get 15. Pretty sweet. Pretty sweet. And I'm going to drag this down here. Next thing I want to do is I'm going to make this maybe like jet screen. Why not? And what I'm going to do is I'm going to hit edit and get rid of these ugly decimal points that they put in formatting wise, right? And here's my normal distribution curve. Now a couple things are happening here. We're talking about how many wins the Jets can get per season, and it may be obvious that they can't get negative 0.6 wins per season, right? That's not going to be possible there. So what I'm going to do is I'm just going to leave that number there from like a mathematics standpoint, but when I do find values and I have negative 0.6, I'm just always going to replace it with 0. But for now, that looks how it should be. So what I have now done is I have finished objective 3. I have labeled a normal distribution curve relative to the data. It looks really great. I'm halfway done with the project. I just need 4, 5, and 6. Great. Let's rock 4, 5, and 6. Next thing I want to do is I don't need the data anymore, so I could kind of maybe move this one up so it's closer. Next thing I'm going to do is I'm going to click on this window here that expands the frame bars, and I can see what I have. I have this blank curve, which I don't need anymore. I don't know why there was a second blank curve, but there were. And I'm going to use this a bunch. So I'm just going to go duplicate, and I'm just going to copy this like, I don't know, make 5 copies so I have enough to finish the document, right? Cool. I'm going to leave the first one blank in case I need it. That was the empirical rule slide. And now I'm going to move on to slide 2 of 5, and I'm going to do step 4 or objective 4, the empirical rule. Remember what the empirical rule says. It says that 68% of the data sits within 1 standard deviation of the mean. 95 or 95.4% of the data sits within 2 standard deviations of the mean. and 99.7% or practically all of it will sit within 3 standard deviations of the mean. So this should be pretty easy. What I'm going to do is I'm going to go up here. I'm going to pick my fancy highlighter, which is the 3rd one in, and I'm going to start with red, and I'm just going to highlight from -1 to 1. Beautiful thing. I'm going to put a dot down here for like a key that I'll fill in later. Then I'm going to go here for blue maybe, and I'll go from -2 to 2 on my blue. Pretty fancy. And now I'm going to get that jet screen for 3, and I'm going to go from here all the way to here, -3 to 3. I see that I'm writing on my graphic there, so I'm just going to take the arrow, just going to move the graphic maybe over, I can put it up a little bit there, maybe make this a little bit smaller on this slide. Cool. You can move stuff around, add different images, whatever. And I forgot to make the other dot, so I'm going to go back to my highlighter. I'm going to take the blue one and put the blue dot here for the key. And finally get the green dot for the key. So this is kind of my key to what's going on here, and then I'm just going to open up a text box and kind of say something. Well, I know the red one is within 1 standard deviation of the mean, 1 above, 1 below. So that's where 68% of the data is. So I can say 68% of the time. So according to our data, 68% of the time, you gotta hit edit if you lose it, the Jets win between 4.6 and 9.8 games. Of course, we know that they can't win 4.6 games, but that's what the data says there. It says that between 4.6 and 9.8 games, and I'm going to go there, and I'm just going to make this just a regular color so it doesn't clash with the other one. Now what I'm going to do is copy and paste that. Copy, paste twice, and put one down here, and put one down here. The second window is the blue one. That's within 2 standard deviations of the mean, so that's going to be 95.4% of the time the Jets win between 2 and 12.4 games. And finally, the last one is within 3 standard deviations, so I'm going to say, and 99.7% of the time the Jets win between -0.6 and 15. This one is a little wacky, negative games, so I'm just going to make that one 0 games. And I don't think the Jets have probably had too many undefeated 16-game seasons, so that sounds pretty accurate to me. Yeah, and we just finished Objective 4, the empirical rule. Pretty sweet. One thing that I might have changed if I did this again was I might have changed when I rounded here the data. I might have rounded it to the nearest whole number, because now looking at these games here, on the empirical rule slide, it's kind of silly to think about it as like fractional or decimal wins, but you know, hindsight is 20/20. That's what I would have done moving back. Cool. We just did Objective 3. We're rocking here onto, oh no, we just did Objective 4. We're really rocking, only 2 left. Objective 5 says use the NormalCDF function to find any 2 other stats and just use at most or at least. Cool. So I'm going to move on to the next slide. Boom. And here you can pick any one you want. So like for me, I'm interested, like in the NFL, typically you're competitive, like you have a shot at winning the division if you get over 10 wins per season, right? So I'm interested in like what percentage of the time do the Jets win over 10 games per season. So I'm going to write X, according to our data, the Jets, New York Jets. Click edit if you lose it. The New York Jets win over 10 games X% of the time. I don't know what it is yet, but that's what I want to find. Like how often are they winning more than 10 games per season? What I'm going to do is I'm going to take the highlighter and I'm going to go to Jet Screen here, and I'm going to find where 10 is. 10 is probably about here, and I'm going to shade nicely this region. And I want to find what percentage is this happening. And look at that beautiful shading there. That's really nice. I want to know what percentage of the time are the Jets winning over 10 games per season. It's clearly less than 50%, because 50% is in half. I'm going to guess it's like 12%. I don't know, 8%. But let's find out. I go to Delta Math. I go to distribution. Bring up my NormalCDF. The lowest number I want to calculate is 10, up to infinity, more than 10 games per season. The number doesn't have to be that large, but certainly it's better if it is. 7.2 is my average. 2.6 is my standard deviation, and I calculate that, and boom, look at that, it's about 14% of the time. I'm going to screenshot this, Command-Shift-4, and I'm just going to go Image and drag in my latest screenshot, which is kind of like the work of what I did here, and boom, that's a beautiful thing. I'm going to take this, I'm going to put it over here as my work, and I'm going to round that. It looks like that would be 14.1% of the time, rounded to the nearest tenth. So I'm just going to click here, click Edit, and write 14.1% of the time. They win more than 10 games. I could even add something like I picked 10 games because I find that teams are competitive in the NFL if they win over 10 games in a season. Usually not competitive. It's very rare to see a team that goes like 8-8 and is competitive. And if I want to be fancy, I can go back here to the highlighter. You know, I can take out the pen or something and just go like here and kind of label that as like 14.1%. Whatever you want to do, you know. Cool. Now, we're not actually done with objective 5 because it wants you to find 2 stats, right? And it says at least one of these should be at most or at least. I just did it at most or at least, and I interpreted the results. So let's go doing one more. I'm going to, again, go like this, boom. And I'm going to do one more. I can pick whatever I want, and I'm going to pick just random numbers here. I'm going to pick a finite interval. I'm going to use jet screen again, and maybe I'll do, I don't know, maybe we want to figure out how often they win between 2 and 5 games, because that's a pretty stinky Jets season. So let's see. According to our data, the Jets will win, drag this, hit edit, will win between 2 and 5 games per season, X% of the time. I don't know what it is yet, but I want to see between 2 and 5 games per season. So I'm going to go here, I'm going to take out my highlighter. We've got that jet screen going. 2 games is here, so I'm going to click 2 here. It's not on highlighter, it's on pen. I like the highlighter. 2 games is there, 5 games is here. I want to figure out what percentage this is. It's a pretty crappy season, but the Jets are not that great. Go back to Delta Math, and all I have to do is change my window. The mean and standard deviation are the same, but just change this in 2 and 5. Calculate it. Get 17%, right? Boom. Command-Shift-4. Copy that. Back to my jam. Hit the image. Drop in the screenshot. Make it a size where you can actually fit it. So this looks like it's about 17.6% of the time. So here I'm going to write 17.6%. I have to hit the edit button here. When I hit edit, I get 17.6%. Cool. Of the time. Here, what I have to do is label this figure here. So I'm going to label this part here as 17.6%. And you can see that the New York Jets are more likely to actually win between 2 and 5 games per season than they are to win over 10 games. So I might add that in there because that's a little cute little observation. So I'm going to click here, again click edit. This means the Jets are more likely to win between 2 and 5 games per season than they are to win over 10 games, which is kind of wild because 2, 3, 4, 5, there's only 4 games they could win there, but with 10, they could go 10, 11, 12, 13, 14, 15, 16. There's actually 7 games there, but yet they're more likely to win 2 and 5 because they haven't played very well. Great. That's objective 5. We only have one objective left. Objective 6 says using the inverse normal function, find either the 10th, 20th, 90th, or 80th percentile. Awesome. So for the next one, what I want to do is I want to find the 90th percentile, meaning I want to find like the percentage of times that the Jets will win, like what number separates the bottom 90% of their seasons from the top 10% of their seasons. That's what I want to do. So in order to do that, I kind of use Google Docs to do it, and I use this formula sheet because it's a little bit neater. And essentially, I want to find a z-score for the 90th percentile, and what I want to plug in is the mean and the standard deviation. So let's do that. Well, my z-score, to find that for the 90th percentile, I'm going to do the inverse normal of 0.90. What I have to do is plug in the mean and standard deviation. The mean was 7.2. The standard deviation was 2.6. So I go 7.2, 2.6. And I just solve this for x, and I'm going to find some x value, some amount of wins per season that's going to separate the bottom 90% of jet seasons from the top 10% of jet seasons. So I go back to delta math. I'm still under distribution, but I click inverse normal and I hit 0.90. And what I find is that the value, and I'm just going to use this value here, is 1.28, meaning that a z-score of 1.28 separates for any data, not just the Jets data, but for any data, separates the bottom 90% of data from the top 10%. So let's go back to our curve and use that 1.28 to label it. So that 1.28, recall, is a number that separates the bottom 90% from the top 10%. And here's 1, here's 2. So 1.28 is going to be between those values. It's probably about here. And again, this separates the bottom 90% of data from the top 10% of data. Maybe for the top, I'll use like a green. And like the top 10% of data is there, right? So that's what that number is. And then maybe I'll do some, I could do some shading here if I wanted to. The bottom 90% from the top 10%. And I'm trying to find this value here, x, how many wins is separated. I know it's between 9.8 and 12.4, but that's what I'm trying to find here. And I am just going to use this formula here to find that x value. Well, first thing I need to do is multiply 1.28 times 2.6. So I'm going to go 1.28 times 2.6. 1.8 times 2.6 gives me 3.328. 3.328. So I know 3.328 equals x minus 7.2. Maybe I'll use a capital X since I've been using a capital the whole time. And now just take 3.328. And I take that 3.328. I could hit answer. It's already there. Plus, and what am I adding? 7.2. Just check that. Am I adding 7.2? I am. That's the mean. Enter, and I get 10.528. So x equals 10.528. And rounding this to the nearest, we'll round it to the nearest win would be x equals 11, right? What I want to do is just screenshot this. So I'm going to go Command-Shift-4 one final time, drop it here. That's like my work here. Now I'm going to go back here on this slide here. Maybe I can take the arrow button and drag all of this over. I can't, and I don't want to. Whatever. All right, I'm just going to drop this in here then. This is kind of the work, right? Ooh, that's nice. Great. Drop that in there. Then I just write a little analysis about that. What does that 11 mean? The 90th percentile of games, the Jets, hit the edit button again, the Jets, 90th percentile of games the Jets will win in a typical season is 11. This means that 90% of the time they will win less than 11 games, and 10% of the time they will win more than 11 games per season. Of course, we rounded. It was really about 10.5, but I took the liberty to round there. And that completes the inverse normal. Objective 6, which means that we're done. Of course, go through the rubric here. Make sure you have everything before you hand it in as you go through it. But that is our portfolio assignment. I hope this video helped you kind of get to the next step if you are stuck somewhere. If you have questions, make sure to ask me in class. And don't forget to jam that like and subscribe button. I'm posting all these videos. There are a lot of work to get up here. And don't you want to hit that little bell button? Subscribe to the channel? Anywho, all jokes aside, thanks for watching the video. I'll see you all in class. Bye-bye.